So today I thought let's start with a very simple and very interesting topic, which is matrices. Now, what is the first question which arises in your mind when you hear the word matrix? Again, what is a matrix, right? So a matrix is nothing but the rectangular combination of array in an ordered form. So what do you mean by ordered rectangular array? Array is nothing but the collection of data. So if we have a collection of data in a rectangular form, it's called a matrix. Let's consider an example. Let's say we have an array A, B, C, D, and we can use it to our benefit, that now this is one array, or I can have a array in a column form as well, A, B, C, D. But when we combine multiple arrays together, we get a matrix. So let's consider that example. Let's say I have A, B, C, D, E, F, G, H, I, J, K, L. Now, if you combine them together, what form we get is called as a matrix. So why we need a matrix, or what is the use of matrix? Matrix can help us in displaying the data or multiple data for multiple objects or multiple subjects. Let's consider an example. Let's say we have uh, three students uh, who carry some pens and some pencils. So let's say we have three students, X, Y, Z, and again this is a toy example, so please bear with me for now. So let's say X carries 3 pens, 4 pencils, Y carries 5 pens, no pencils, and Z carries 1 pen, 2 pencils. Now if you see here, do you see a similar form to that of a matrix? So if I rewrite this in a simple way, I'll get what? 3, 4, 5, 0, 1, 2. Right? So this is nothing but a matrix. And so we can see there are multiple rows and multiple columns. Now in this particular scenario, the rows represent the student and column represent number of pens and number of pencils. So now these numbers which you see here in a matrix are called as an elements. Now these elements can be functions as well, or any number. So you can say it's a complex number, imaginary, pure imaginary number, pure real number, pure irrational number. It's completely fine. So understand that when you are talking about these elements, it can be either a function or a number. Now you may ask, how can I write functions in a matrix form, right? So let's take another example. Let's consider a matrix A which looks something like this: sine theta, cos theta, tan theta, cosec theta, sec theta, cot theta. What do you see? Yes, that these elements now, each element of this matrix A are trigonometric functions, which means the elements of a matrix can be a number or a function. So can you make an array, or make a matrix which will include some complex number? Let's see, 1 plus 2i works, 2i plus 3, sure, it's a complex number. 4i, it's an imaginary number where real part is 0, so absolutely. And 5, where imaginary part is 0. So you can use a matrix to create any form, or the elements can take any form. So it can be a number or a function. So moving on, the next part which I would like to discuss with you is order of matrix. Now, what do you think order of a matrix would mean? So, in simple term, order of a matrix represents or talks about size of matrix. Matrix in terms of rows and columns. So, order of a matrix is nothing but the size of a matrix in terms of rows or columns. Rows and columns. So, simple, let's consider a matrix. Let me copy a matrix from which we have made. So let me just copy this real quick. Okay. And yes. So how many rows do we see here? 1, 2. So 2 rows. And how many columns? 1, 2, 3. 3 columns. So the order of matrix will be 2 cross 3. So how do we signify the order of matrix? We say order of matrix is if the form number of rows into number of columns. So as we have 2 rows here, 2 times 3. So let's consider a general matrix. Okay. Yeah. So let's say A11, A12, A13 up to A1n, A21, A22, A23 up to A2n, A31, A32, A33 up to A3n, and we can extend this to AM1, AM2, AM3 up to AMN. So, can you tell me what is the order of this matrix? Yes, so we have how many rows? 1, 2, 3 up to m rows, right? So let's write number of rows m, and how many columns? 1, 2, 3 up to n columns. So m cross n. Now, why did I write this? So if you look at the general element here, let's consider A23. Do you see? It is the element in second row and third column, right? Or A31, element in third row and first column. Make sense? So can I say in general term, Aij is an element in ith row and jth column. Simple. So using this, you can pinpoint to any element based on its row and column. Just like in coordinate geometry, how do we represent a point in x and y coordinate? In matrix, we use number of rows or which row and the number of column. So we can pinpoint to an element and it will be universal. Now let's consider one example where we'll be constructing a matrix based on given condition. So the question is, construct a 3 cross 3 matrix A where each element is given by Aij is equal to half of I plus j, which means that you have to add which row and which column the element in and divide it by 2. So simple. Let's see. Now as we have to make a 3 by 3 matrix, let's make a general 3 by 3 matrix first. A11, A12, A13, A21, A22, A23, A31, A32, A33. And now we have to identify each and every element here, right? So what we can do, A11 will be how much? Half of I is equal to 1, j is equal to 1. So 1 plus 1, which is equal to 1 by 2 of 2, which is 1. Same way, can we find A12? 1 by 2 of, now I is equal to 1 and j is equal to 2. So I have 1 by 2 times 3, which will give me 3 by 2. And the next term, A13, again same idea, 1 by 2 times I is equal to 1, j is equal to 3. So 1 by 2 times 4, which will be 2. So on, and if you can keep finding all, you will find A33 is equal to 1 by 2 times I is equal to 3, j is equal to 3, which will be 1 by 2 times 6, which is equal to 3. So now I can form my matrix A, right? So A is equal to 1, 3 by 2, 2, 3 by 2, 2, 5 by 2, 2, 5 by 2, 3. And this is my matrix A. So to conclude today's video or today's short session, what is a matrix? Matrix is nothing but the ordered form of rectangular arrays, and when we combine arrays in rectangular form, or when we combine arrays in rectangular form, we get a matrix. And what is the order of a matrix? Order of a matrix is nothing but the rows and columns present in a matrix. Clear? So in this way we have started matrix. In upcoming videos we may look at special types of matrices and how to perform algebraic operation on matrices, so on and so forth. Thank you.